In lesson 12.2, we're looking at expressing and identifying solutions of inequalities. And a reminder that an inequality is simply a mathematical sentence except it contains the following symbols. We have a symbol that looks like this, which means that it is less than. We have our greater than. Then we have the ones that have that little horizontal line below it. And so we have our less than or equal to. And then we have the opposite, greater than or equal to. And then we have our not equal to sign. And we've talked about this one before, where it's an equal sign with a line through it. So when we graph these, a graph of inequality shows all solutions of that inequality. And then a solution of an inequality is any number that makes the inequality true. Alright, and when we graph them, we have two identifiers. Obviously we're going to use, when we graph, don't think of it as like a line graph as much as we have a number line that we graph on. And one of the identifiers of an inequality on a number line is if we have a circle and it's just an open circle. So our open circle, this means that it shows that the number is not, I put that in blue to kind of make it stand out, not a solution. And then we have the opposite of that. And the opposite of open would be closed. And so we put a closed circle. And a closed circle, well, it's the opposite. It shows that the number, and I'll put that and stress it out as is a solution. So let's look at some examples as we go forward, but keep in mind that if it's an open circle, it means that everything leading to that is true, but not the number itself. And then if it's closed, the number itself is part of that solution. So let's first look at an example of just turning a sentence into an inequality. So putting words into an inequality. So Maria threw the softball more than 90 feet, right? An inequality that represents the distance. So we're going to let D, that's our variable, D be the distance that Maria threw the ball, and then is more than. So I want to put D down here, and then the distance that she threw the ball is 90. But we want to know, how do we say is more than? Well, if I were to say, could she have thrown it greater than 90? The distance she threw the ball is more than 90 feet. So if she threw it 100 feet, would that be more than? Yeah. So if I plugged in 100 for equaling D, is 100 going to be greater than 90? Yes. And would that make the sentence true? Yeah. She threw the softball more than 90. So D is greater than 90. And the 100 is just an example. So it would be like saying if I said, well, if she threw 80, Is 80 more than 90? No, so that would not be true. So if we put 80 is greater than 90, well, no, that doesn't work. So the greater than symbol here would not work if I used 80. So let's look at a quick check. So here you're going to read a sentence and go ahead and put it into an inequality. Alright, skydivers jump from an altitude of 14,500 feet or less. Write an inequality to express the altitude from which skydivers jump. So we have to first think of, well, I've got 14,500. Alright, but I need to think of, and I'm going to say A is my altitude. A is the altitude. So if I want to write an inequality for 14,500, they can jump from 14,500, right? If they jump from 14,500, they'd be fine. However, they can jump from anything less than 14,500 as well. So the inequality that I would want to write would be anything equal to or less than 14,500. And remember that this little bottom part, the bottom horizontal line, that is like the equal sign, this bottom portion of our equal sign. This part right here, the bottom line, is like saying that's the bottom line of our inequality. And then the top part of it shows the inequality of our inequality. It's going to show that it is less than. So let's look at now graphing them. So everyone in our class is 10 years old or older. Write the inequality for the solution. Then graph the inequality. So let A, so they gave us our variable, so we have to use A for our variable, the age of each person in our class. So A is, and we have to look back at our sentence. Everyone in our class is 10 years old or older. So and then A is everyone's age. So everybody is 10 years old. So that'd be like saying everybody's 10, equal to 10. Or older. So A can be greater than 10 too. So when I plug in, and I've got my number line here, I'm going to say, well, everybody can be equal to 10. So if I look back at my notes of saying, well, open or close circle, if I use a closed circle, that includes the number. The number is part of our solution. Oh. Let's go back to the actual problem. The 10 can actually be part of our solution. So I'm going to put my closed circle at 10, right? So I'm going to use a closed circle. And then to say that people can be older than 10. So when I draw my arrow, I'm going to either draw it to the left or to the right. Well, everybody can be 10 or older, so that means I'm going to draw my line going to every number greater than 10. And you put an arrow on it because this is an inequality where it shows every solution. So everything greater than 10, this arrow would go on forever, infinitely to the right. So everything greater than that is part of our solution. And it's also good practice to write it above our number line if we can, so that if, as you guys are using maybe a pencil or even a black pen, if I put it down here on the line and then I just drew my arrow down here, if I draw on that line, it kind of can get lost on our number line. So that's why it's good practice to put it above. It's, understood that if you put it above it, I'm looking at the 10 just below and the number line I can see. Alright, and then let's look at another one. In order to get a bulk discount, a company must order at least 15 computers. So at least 15 computers. Company X ordered 17 new computers. Do they qualify for the discounted rate? So we're going to use C for the number of computers ordered, and the order is at least 15. So it can be at least, at the very minimum, it can be 15 computers. So it's like putting my equal sign down here. And then could they order more and still get the discount? Absolutely. So I'm going to put my greater than. So anything greater than 15 also applies for that discount. So 17 is greater than or equal to 15. Is that true? Yes, that is true. That's my proof. 17 is greater than 15. So company X does qualify for the discounted rate. All right, and then you go ahead and try these next two on your own. All right, you spend at least 2 hours studying. Write the inequality for the solution, or for the situation. Then graph the inequality. So if I want to say you spend at least 2 hours, so if I wanted to say S is going to equal, hours spent studying. All right, there we go. Hours spent studying, and I'm going to compare that to 2 hours. Well, could you spend 2 hours? Is that at least 2 hours? 2 hours is at least 2 hours. So that's going to at least be equal to it. All right, so that's why I draw my horizontal line here to at least get the equal part. But then could you spend more than 2 hours studying, and that would be at least 2 hours? Absolutely. So I'm going to put S is greater than 2 hours, because I could put any other number in for S that is greater than 2. So 2.1, 2.2, 2.7, right? I could even say, 4 hours studying, 5 hours. All those numbers are greater than 2. 2.0, that is still 2, so that would still apply. That would work for S. So now we look at our number line. All right, so I'm going to draw a number line here, and all right, so let's actually try to clean that up just a tad. So I have a number line, and lost my arrows at the end of it. And when we graph, I don't need to put every little, mark for every number, infinitely possible. So I'm going to write the number that I am comparing, right, to. That's what I'm looking at. I'm going to write one less, and I'll write one more, right? Because this is a number line. It goes on forever. So if I'm looking at 2, that's my middle number, right? This is where the prime idea of a good mathematician is a lazy one. Why add more work? I can identify what I'm comparing to, and then I can identify the numbers less than and greater than. As long as I have arrows down here, it works. So any number that is equal to 2, so am I going to use a closed circle or an open circle? Hopefully you chose to put a closed circle, because we are including 2 in our answer. And then everything greater than 2, well, that'd be drawing our arrow, our line, to every number greater than 2, so we're going to the right. Alright, now for number 3, you must be at least 48 inches tall to ride a certain roller coaster. Ian is 3 feet 11 inches tall. Is Ian tall enough to ride the roller coaster? Well, here we actually have to do some math before we can compare. So 3 feet 11 inches tall. Well, I know that there are 12 inches in a foot, and he's 3 feet tall, so that's going to be 36 inches. But I'm not done yet, because he's also 3 feet 11 inches. So I'm going to add to my 36 inches, I'm going to add those additional 11 inches, and I get 47 inches. Well, when I compare 47 to 48, well, 47 is less than 48. It's not even equal to it. A 48 is the only number to be equal to 48. 47 is less than 48, so no, Ian is not tall enough. And my proof would show, one, how I got my 47, but also saying 47 is less than 48. That's my proof. It says 47 is less than it. All right, so that is the end of 12.2 as we look at expressing and identifying solutions of inequalities.